In this video, we'll talk about how to debug your code. Let's say we're trying to make a screen like this. A UI label on the top portion of the screen with two different styles. There is a trick of creating UI label with multiple font styles on it, and we'll talk about it a little later. But now let's just focus on the look of the screen. And here's our code. Apparently, this doesn't work. Typically, you'll encounter three types of error when you are when you're programming your app. And the first type, as shown here, is called a compile time error. It's generally a compiler telling you what's wrong with the code during the compile phase. And if we're trying to build right now by pressing Command B, it will say it's build failed. And that's indicating that there is something wrong with your code and the compiler couldn't figure it out. As you can see, compile time error usually accompanied with a flag that specify the error message. And here it's saying that cannot assign value of type void to type ns attributed string. And here's the easy fix. And here's the reason why. Because the append method doesn't return a value after it mutates the string. It simply mutates the original object. This whole statement will return void. And because attributed text is expecting an ns attributed string, this won't work. Of course, the easiest fix would be just move it to another line and reassign the mutable attributed string. And this will fix our compile time error. However, if we try to run our code right now, it will compile. It says build success, but it won't work because, as we'll see right here, it's saying a fatal error, thread 1, unexpectedly found nil while unwrapping an optional value. And here's the second type of error that you'll encounter, a runtime error. This types of error will crash your code, and it will print out some error message and invoking the debugger called LLDB. The first thing we're going to notice is this error message right here. However, most of the time you will not see an error message like this. Sometimes it will goes into the app delegate and throw an error message here, in which time you'll get really confused because you never changed app delegate before. Well, this is just how Swift debugging works. Most of the time, the thread pointer doesn't necessarily point it to the place where the errors are. And it's just in this convenient case, we have this pointer pointed to our nil force unwrapping, which is here. So the general method of debugging and runtime error like this will be to take a look at your the console output on the bottom right. This will be the console output above the LLDB command line prompt, and usually it's accompanied with a lot of other outputs such as stack trace. So it is important to scroll to the top and find where that error actually is. In this case, it will say fatal error unexpectedly found nil while unwrapping an optional value. And it also tells you which line it is, but that doesn't happen every time. It only happens when you have a nil force unwrap. So if you have a lot of information on the debugging screen, you want to scroll to the top and look at the error message. So here, to fix that, the fix is actually pretty straightforward. But before that, let's take a look at what this program actually does. We have a view controller inherited from the built-in UI view controller. That's the way of customizing UI view controller, as we talked about in previous lesson. And then we have an optional string value representing the name. Recall that the optional value could represent a valid string or a nil. And this is exactly where our error is, because we force unwrapped an optional string while it is actually a nil. This will crash our code. But let's move on to other parts of our code as well. And the second, we have a private title label that's of type UI label, and we initialize it with a closure that we mentioned in lesson 0. In the closure, we create a UI label, assign an attributed text assign its attributed text to an NS attributed string with the string welcome and the attributes font equal to system font 25 points and then style the weight bold. What this does is create an attributed string. The attributed string is a sort of special string object that comes with its own text style or background color, foreground color, etc. It's basically string with a style. And the way we create this composed, this label with multiple style is through using composed attributed string. We have one attributed string of welcome, which is bold, and next we'll create another attributed string with name, which is regular, and then we'll use the NS attributed string to compose these two attributed strings together and assign it to the label.attributed text right here. The label.attributed text is a special place for an attributed string where the label will then read the attributed text and apply its style. In this case, we have two style corresponding to two portions of the string. And next, we'll set text alignment equals sender and then return the label, in which case the return value will then replace the return value of the closure and used to initialize the UI label. Next, we will have the view.load override to specify the styling after the view controller has been loaded into the memory. Remember to always call the super.view.load for every override function that doesn't have a return value. Before we do anything, we want to add subview to a title label to the subview, because otherwise we might forget to add the subview before we activating the constraints, which is not allowed and will cause a runtime error. Next, we will conditionally bind the base attributed string to the title label.attributed text, because the title label.attributed text is actually an attributed string optional. Then we will go into mute. We will create an NS mutable attributed string object and start composing in this, which we call appending the attributed text that we created. The base attributed string would just be the NS attributed string we created here, and then we'll also append a new attributed string using the name variable right here. And finally, we will assign the final version of the mutable attributed string to the title label attributed text. Well, finally, we set our constraints. Well, in this case, if we want to fix the first unwrapping issue with our name string, we can do several things. One, we can for the first one, we could conditionally bind this conditionally bind the optional string to a non-optional type using the if-let statement, and that will look like this. However, it is also possible to create a default value for a optional type in the case where it is nil, and that's through using something we called a optional coalescing operator, and it will look like this. So let's suppose when in a case of name being nil, we want this expression to give us a default value. We can use the no coalescing operator (?) followed by the default value, let's say ASCII. And what's going to happen here is that when name is nil, in this case it is, the evaluation of this expression will defer to the right-hand side of the operand, which is ASCII. So if we run it right now, we shouldn't see anything because there is another issue with our code. And this is the third part of error that we're going to talk about. This is not a runtime error or a compile time error. It's just something that sort of is something wrong with your code, and then the compiler and the runtime both decide to go along with it because that's an acceptable thing, but it creates undefined or unwanted behavior like this one. However, in this case, because this is a constraint conflict, it actually outputs a lot of stuff, a lot of debugging information on the screen. It's just that it doesn't throw anything or it doesn't create a fatal error. However, it is still useful to take a look at these debugging output because that will give you a lot better idea of what's going on. And in this case, it's saying auto resizing mask layout constraints, and that should immediately rings a bell. Because in the last lesson, when we talked about how to create a constraint, we also talked about you have to disable the default frame conversion behavior in order to make your constraint works properly. And in this case, because we initialize UI label without a frame, what is implicitly saying is that initialize it with a frame 0, and by default, this frame 0 will be converted into constraints, which will essentially make our UI components UI components invisible. So to disable this behavior, to disable the behavior converting the frame into an outer resizing max layout constraints, we need to say label.translate outer resizing max into constraint to false. And this will disable the conversion of frame 0 into constraints, which will cause our view to be invisible. Now you will see the name label, the label that we created start appearing in the center of the screen, which is still kind of weird because we wanted to pin it to the top of the screen. However, this time there is nothing printed on the console output because this is something wrong with our code, and it doesn't even cause a constraint conflict, so there is nothing output. However, to find error like this one, to find the constraint issue like this one, it is often helpful to use this view hierarchy tool. What this does is that it renders your user interface at the time of the execution, and it converts it into a 3D view. Looks like this. So right here, you can immediately see what's wrong, because what we're creating here is a very big frame, and what the UI kit is doing is placing the label in the center of this frame, right? So to sort of make it only appears on the top of the frame, we need to remove the constraint that's restricting the bottom anchor of the UI label to the bottom anchor of the view, in which case would be this constraint. Now you might be wondering, but then we sort of not specifying the size of the constraint and the size of the view, and how is that possible? Well, in the case of an UI label or UI button, we don't always need to assign the size. We don't always need to explicitly provide the size of the label, because it can be inferred from its content, such as font. And in this case, this is exactly what's happening. We only specify the top, leading, and trailing anchor, and the height of the title label is inferred from the font, which is like the size of the content, and that's called an intrinsic size of an UI component. Well, so here, if we run the view hierarchy tool, we can actually see the frame got a lot smaller and is working as we expected. There are other tips and tricks for debugging, such as you can create a breakpoint. What breakpoint does is that it stops the execution at a certain point of the program, and it will give you access to all of the variables and the expressions that's available at that point of the code. So, for example, if I choose to stop a breakpoint here, it will stop inside this view.load function, and it will show me the self, which is an object referring to the view controller, and we'll be able to see what's the title label and what's the name string in this object. And this is actually very helpful. And so combined with other commands such as step over, you'll be able to see the flow of your program and step by step to be able to figure out which steps went wrong. Another useful thing that I want brought to you guys' attention is the LDB debugger here. So you can actually type expressions into LLDB, and it will evaluate that expression and give you the return value. So for example, if here I want to see what's the value inside the title label, the attributed text, I only need to type expression, which is a command in LLDB, and it will say enter expressions and terminate with an empty line to evaluate, right? Then I can start entering the expressions such as title label dot let's say attributed text, and it will say it will return the string representation of the NS attributed string, in which case we can see the string is welcome and the attributes are a reference pointing to an attribute object. You can also create a memory graph, which will not be super useful until we talk about automatic reference counting, but just keep in mind that this is here. This is so much for this video. Thank you for watching. I'll see you next time.